Hello, everybody.
Hello, Doug.
Hey, Doug.
Me. Eric. Yo, Tommy.
Yo.
And Hal, you there?
Morning.
Morning. You have a nice vacation, Clemens?
Yes, indeed, I did.
That's good.
Yes. The longest and most beautiful beach in Germany.
Nice.
Yes. And now people are like, what do you mean, beaches in Germany? But yeah.
Well, let's quickly bring up Google Map. Oops.
Hey, Doug, it's Jesse.
Hey, Jesse. And Ginger.
Oh, gotta find the unmute button. Hey.
Hello. How's it going?
It's Thursday.
It is Thursday. Yes. Matt, are you there?
Yep. Nope.
Excellent. And Simon? Oh, Simon has no mic yet. Hey, Simon.
Hello.
All right, let's go back and check. Germany. So you went north then, Clemens? Where did you go to?
I went north and then to the east, and that is as close as you can get to the Polish border is the island of Rügen. And as on the east side of that is a enormously long beach, which is like 15 kilometers, and it's all white sand and it's beautiful. And it also has a architectural noteworthy building or set of buildings, which were built just before the Second World War. And that's a 5 kilometer stretch of just one giant block of hotels that the Nazis built and that have now been taken over by the modern Germany and are being finished as a absolutely amazing resort. But it's basically a 5 kilometer stretch of all the same buildings. It's pretty remarkable.
Interesting. And
Yeah.
temperature-wise, I assume it was very nice.
It was very nice, yes.
Cool.
Yeah, and then unfortunately, all the bad flooding that you all saw in the news, that is to the east of me and to the west of me and to the south of me. But luckily, we were spared. But it has been raining 3 days very hard here.
Yeah, I saw some of the news coverage of that. That's kind of scary.
Yeah, I think by my house we easily got like 50 liters on the square meter. So it's sorry if that doesn't mean anything to people in America. But yeah, it's been raining super hard.
Dumb Americans, yes.
Yeah.
All right. Oops, where's my cursor? All right, hi, Daniel.
Hello.
Right. Where is everybody? So I may have found somebody to take over the SQL expression stuff since Slinky is off doing other things. So we'll just have to see how that goes. Hopefully this new person will be able to present it to the group soon. Just let you know. Okay. Oh, there it is. I thought I saw someone join. Hey, John.
Has Slinky moved on to greener pastures?
I don't know about greener, but he's definitely moved on. I think he left Red Hat. I think he went off to, he mentioned the company name and I cannot remember the name, unfortunately. But I think he left Red Hat. Hey, Klaus.
Hello.
So while we're just waiting here for the 3-minute mark, I hope you're okay with this. I decided to try to tackle hopefully a relatively easy issue first. Then Clemens, you do your thing on the schema registry, and then we'll go back to issues because I wasn't sure how long these two were going to take, and I didn't want Clemens to run out of time. But if you could still keep it within 30 minutes, Clemens, I think that would still work.
Yeah, that will work.
Okay, cool. All right, it is 3 after, so why don't we go ahead and get started. All right, okay, anything from the community people want to bring up that's not on the agenda? All right, last time I checked, we did not have anything SDK agenda doc for this week, so if you have anything, please add it before the end of this call. Otherwise, we will skip that meeting this week. Nothing new from KubeCon as far as I know. I don't see Timur on the call, so he's not here to update us. So let's jump right into it. Okay, we have 4 different issues. 2 of them are actually carryover from last week. These 4 issues are ones that I'd like to close. The reason I left the 2 from last week is because no one commented on those, and I feel a little uncomfortable unilaterally deciding to close them. So if I can get at least one person jumping on there saying, yeah, it sounds good, let's go ahead and close it, I'd appreciate that. And then these 2 are relatively new. So I'll wait until closer to next week's call to see if people have any comment on it. Please, over the next couple of days, look those over and see if you're okay with closing those. And with that, let's go ahead and jump over to Eric's PR. All right, Eric, is there anything you want to mention here that may have changed since last week?
Nothing of substance.
Okay, nice and short. What was I going to say? So there was I'd made a couple of comments, unfortunately, relatively soon or close to this call. Where was it? There was one I wanted to bring up. Yeah, that's just a wording thing. Sorry. I think it may have just been the soft delete thing. Actually, no, I guess there are 2 things. I guess I wanted to bring for the group.
If you're
This one
looking for
here.
discussion topics. Oh, sorry. Just real quick. If you're looking for discussion topics, I put what I thought was the highest priority in the write-up of the PR.
Oh.
But let's go ahead and discuss this. What you have on screen.
Oh, okay. Let's go back. Okay. You want to talk about this one? Right, in particular, this comment? Eric, do you want to talk to it or do you want me to?
Go ahead, actually, if you like.
Okay. So correct me if I'm wrong here, but what Eric's talking about in this case is there are certain operations like on a delete or some sort of update command where the response returns not just the ID and the epoch of the value itself for cases, at least, which is really useful in cases where you're returning multiple objects or you're processing multiple objects, so you know exactly which objects were touched. But then there's this whole question of, well, is the ID and epoch sufficient, or should it return the entire old copy of the resource? And it is old, not new, right, Eric?
That's right. Yeah. So the place where I had this happen is in a delete. So when you're deleting, you send just the ID and the epoch. Although I think you can get away with the epoch without the epoch anyway. Details are specified in the spec. And once that's deleted, that would then return to you the value that was deleted. And that helps in cases where you are doing something else with that data, or maybe you want to log it in case there was an error, or who knows what, but that can be helpful. And but I only did that on deletes, and it seemed to me that there could be an argument to made to and I'm not really strong on a particular use case where I'm like, I need to have this, but just to put that out there. But in the case that you're doing something like a post or and you're updating a record, it might also be useful to get the old values. And I've seen this in DynamoDB, for example, and particularly when I was doing things with kind of an optimistic lock, I found that to be helpful in some cases. So anyway, that's that kind of concern within this API. And it's not entirely consistent. I'm only doing it for the deletes, like I said. But it seems that there could be an argument for just not doing that because there's not enough value, or for kind of conditionally responding with just the IDs in the case of a creation and with the entire value of what was replaced in the case of an update.
Yeah, I think I just want to bring that up from the group because I think it's an interesting discussion point. Does anybody have any opinion one way or the other on that?
Yeah. For put and for post, generally, so post is for when you create something and then the service goes and does some basically assigns the ID. For me, that's the difference between the two, between post and put for when you're creating something. One is you have an opinion about what that ID should be, and then that's the put, and then otherwise you have the post that kind of determines that. I would expect that for create an update that that you're getting the entity as it then exists, so that you're getting the updated one, because the service might go and choose to augment it with extra information. So if you think about server-side extensions where you are supplying, so you're supplying a standard document, but the service implementation actually adds further implementation-specific metadata and the default values because you didn't supply any, then you will want to know about those default values that were added, because ultimately that's the picture that is then effective in the service. So for anything that's create an update, I would not want to see the old version, but I want to see the what's current as the result of a 200. Delete is indeed special, but it's not weird to return something out of a delete, but it's not it's not as expected to get something out of a delete. So the one case I can think of where we are in our world returning something out of a delete is we actually modeled dequeuing messages from queues with deletes as a fire and forget mechanism. And with that, you are effectively deleting from the top of the queue, and the thing that you just deleted is being returned to you as the response. So it's not outlandish to go and model it that way, but there is a but for as I said, for the update and create path, there is no other good way to get at whatever the server supplied defaults are, other than returning them for the current value, other than returning the current state of the object with as a return code. And I understand that's inconsistent. If we were returning something on the delete, it seems impossible to reconcile the two into a consistent, like we always return the current state of the object.
Yeah.
Even though, sorry, if since I'm always thinking in the raw here.
In the raw, I like that phrase.
In the raw. I mean, you can convince yourself that you're always getting the latest state of the object, and if you delete the object, you're returning the latest state of the object, and then you delete it. I think we can twist our mind into that direction to say, yeah, you're always getting the latest state of the object, and in the case of the delete, you're getting the latest state of the object, but it's gone now once you've got the response.
Eric, what are your thoughts?
It's interesting and it makes some sense. I'm pondering.
Yeah, no, I like the idea of I like your argument, Clemens, on the create and update side of things. On the deletes, I don't have a problem. I don't have a strong preference either way. I do think if we're going to do this, though, we should probably make it a little more normative in the spec and not do it by way of example.
Mm-hmm. Yes.
But Eric, it sounds like you were, at least when you wrote up the PR, you were leaning more towards going and returning everything. So I'm not hearing anybody object to that idea. So maybe we should just make it a formal thing in the spec with text as opposed to just example. What do you think?
I believe it was actually formal, isn't it?
Oh, is it? Maybe I'm remembering incorrectly. Oh,
Yeah,
there you go. Never mind. Okay, and then we'll go back up to the previous one.
I haven't done that there. In the post, I'm simply returning, specifying the return of the ID and epoch, particularly because those can be supplied, as Clemens was pointing out, by the service itself, or sorry, the endpoint itself.
Wait, I'm sorry, say that again. You're saying you did not return it on the update because...
I didn't, the notion of returning any of the service from the post has been so far just something in discussion, not actually something expressed in the spec.
Got it. Okay. Okay. Well, I was thinking for the outstanding things, maybe we should treat all those as follow-on PRs anyway, and maybe that could be one of them. That way, if people are okay with the PR as it stands today, we can merge it, and then you can do follow-on PRs to twiddle things as necessary.
I'm happy to do it either way.
Okay. Right. The other thing that I thought might, well, you said you put them in the top. Okay. This one's soft deletes. Want to talk to what this one's about?
So, as I recall, there was kind of an opening left for soft deletes if a service wanted to, or an endpoint wanted to provide that. And I'll just probably read this before I start speaking too much. Oh, right. So yeah, it was a good question. You asked whether when get is performed, whether the soft deleted services should be included there. And my inclination is to say that they should be, unless they're filtered out. But I don't know. Yeah, I wrote my text.
Okay. Yeah, I'm not necessarily, personally, I'm not necessarily against the idea of a soft delete. It's just, if we're gonna do a soft delete, I think we need to fully define it with its life cycle and how you can turn the soft delete into a hard delete, how you can resurrect a soft delete. And because we didn't have all that other stuff in there, until we do, I'd rather say just delete means it's gone.
Yeah.
I'm certainly okay with that. I can just remove all mention of soft deletes.
Yeah. And like I said, I'm not against soft delete, but I think we just need to be clear about what it fully means, though, right? As opposed to sort of a half solution.
I agree.
Okay. Does anybody else want to chime in? Thank you, Clemens. Anybody else want to voice an opinion? Okay. And then the third one, unsupported filters, you want to talk to that one?
Oh yeah. So you raised, so what I had put in was just a generic provide filters, and I left kind of unknown or unstated what should happen if endpoint receives a filter that it doesn't support. So the only mandatory filter is to be able to filter by name. And but what you were recommending is that we reject any unsupported filters with an error, and which is interesting. It's the logic of it, but part of what that makes me think about is that then how is say a tool going to know what flags are supported, right? Because that's easy to do in documentation. If we think a little bit about the HTTP scenario, you can ask an endpoint what verbs it supports by asking, calling the options. But this seems like a whole rabbit hole to go down. Although I could see it being semi-appropriate for some use cases. So that's that. It seems like it's opening a can of worms that I was kind of intending to stay away from, but yeah, I don't know. I'm happy to do what seems sensible.
Okay, let me just comment on why I commented there, and it's pretty much in my comment already. It's just if we allow the server to silently ignore things, then the client has no way of knowing whether the filter was taken into account or whether those things were just silently ignored. And if they're going to base the results on that filter criteria and going to do something with it, with the assumption that the filter actually applied, then they may end up taking the wrong result as they may interpret the results incorrectly, basically, is what I'm worried about. And to your concern about how does the client know what other things are supported besides just the name, I agree with you that as of right now, it'd be a documentation kind of thing. I think we could look at supporting some sort of discovery mechanism, right? I think that, as you said, though, I think it gets into a whole can of worms. But we can look at that if we really want to. But for right now, I think I'd rather keep it simple and make sure the client knows exactly what they're getting back. And if the server doesn't support what they're asking for, I think it's safest to say, sorry, you asked for something I just cannot do. But
It is definitely safer.
Yeah. Does anybody else want to chime in? Does silence mean you agree or disagree? Don't care? I'll pick on someone if I have to. I'm going to pick on Lance, just so I can get him on the attendee list by hearing his voice. Lance, you have an opinion on this one?
No, I have to be perfectly frank. I was commenting on another GitHub issue about the SDKs bubbling up non-CE data, and I wasn't paying attention.
Oh, hey, at least you're being honest. I like that. Thank you.
I apologize.
Okay, let's try David. I haven't heard David yet. David, do you have an opinion on this one?
I do not. Sorry.
Okay, fine. Okay, I'm going to assume silence is no strong opinion either way. So, Eric, you okay with doing a?
I'm okay with that.
Okay. All right. Okay. Okay. So personally, well, okay, let me turn this around. So I think Klaus, you were the one who asked to have another week to review this one. Are there issues you want to bring up related to it that you want to discuss? You okay with it? What's your take on it?
I think I'm okay. I had a closer look today, and first did not understand this term service instance, but it was clarified, so it's fine.
Okay. Okay. Does anybody else have any comments, questions, concerns? Want another week or more? Okay, not hearing anything. But then I think I'd like to is ask for formal approval. And we can, Eric, you can decide whether you want to just incorporate some of the wording things part of here, because I don't think there are any significant wording changes, or whether you want to save those for separate PR. You can decide, just let me know which way you want to go.
My assumption was that I would incorporate those changes. They're straightforward and don't seem controversial.
Okay, sounds good. Okay, and as always, this is not set in stone. We can do PRs later in case something gets messed up between now and the time we merge it. Okay, so formally, any objection to approving Eric's PR? All right, cool. And thank you, Eric, for all the work and your patience as we take the time to review it. I can't remember, what did you decide you were going to do on delete? Include the objects or not?
Actually, that seems unresolved at this point. I liked what Clemens was suggesting. I think that brings some consistency to it. That although there's a little bit of an inconsistency at a delete, we would hand back what the value of the record was prior to the deletion, and then with a post or put, we will hand back the value of the record after the application of the change.
Okay. So there you go. Okay, just so we have notes of it. All right, cool. Thank you. All right, Clemens, are you ready?
I'm ready. I think I might be ready in a second. Hang on. I should. Yes, hang on. So let me find the right controls in this window.
Okay. Oh, while we're waiting for him to get that all set up, I can't remember who else presented. Anyway, for everybody that's presented these review the specs things in the past, point me to where your presentations are so I can upload them to a common spot. I have had people ask for the presentations, and we want to make those available to folks. So just let me know where they are and I can put them in the right spot. And with that, it's all yours, Clemens.
Okay. You should, I have too many screens here. You should see one screen that only shows you one slide. Is that right?
Correct. Cloud Event Schema Registry, yes.
Perfect, great. Okay. So then let's start. So the Cloud Event Schema Registry is a specification that defines really a very simple file store, if you will, with a little bit of extra structure. We are in eventing in general, and may that be event streams or discrete events, we are increasingly using schema-bound formats. So we already in Cloud Events have Avro, we have Protobuf. So those are formats which require a schema to be for the payload or for the event per se to be deciphered. So if you just get an Avro payload or a Protobuf payload and you don't have the matching schema for it, you just can't decode it. So that's more and more common. And there's several reasons for having schemas overall, and then also for having a registry in where you can store them. So the first reason for having schemas is validation, where you are getting some data that you can decipher because the format itself is structured enough, like JSON or XML, and so you can parse it no problem. But there's further rules to the schema that determine of whether the message that you're getting is valid or not, whether you produce it or whether you consume it. So having a schema, for instance, a JSON schema, allows you to determine whether a message that has been given to you is valid. You can go in and validate it using the schema, and only when it passes validation, you can then pass it on to your internal logic, which then handles the message. The second reason is, and that's why Protobuf is popular, and why Avro is popular, and why Parquet is popular, and why all those other schema-bound formats are popular, is efficiency. Because schemas contain all the metadata and the type information in an external document, and what remains on the wire for any given message is really just the pure data, and all the delineation information, which means where does a field start and how long is it, etc., is all encoded in the schema in some fashion. And then the last one is that you, particularly in message-oriented systems, you want to be able to go evolve messages. So over time, you want to be able to send messages that contain more information or that might omit information. And to be able to determine whether it's possible to go and add a field or remove a field, you need to keep effectively track of the history of a particular message and its evolution in a place. And then you also need to be able to determine by analysis of whether a new schema that you're adding will be backwards compatible with the prior schema, which is something that is relatively straightforward to do on simpler schema formats like that for Avro or Protobuf, and which is mind-bogglingly difficult for something like JSON schema, because that is just crazy complex. But for most schemas that are used for efficiency, which means for compactness, that is typically doable. So what you will do is you will use a schema registry to keep track of all the schemas that have been used for a particular kind of message. And if you're evolving the schema and you're publishing a new schema, you can now use the schema registry to check against whether the new schema is backwards compatible and therefore permissible against the registry. We're in the CNCF spec as of today. We are not defining that compatibility mechanism, but that compatibility mechanism can be easily built on top of the foundation that we're having as an extension. And then furthermore, we allow a schema registry also allows for governance in various forms. Again, that's not a use case that we're covering explicitly in the CNCF spec, but it's something that is where a specification, where a registry like this is required. So it's a foundation for further functionality that a platform can build on top. And what I mean with governance is that, and that's also going to show up in the federation slides that I'm going to talk about. It is very often so that in very large companies, the schemas that are being used, the formats of messages, are not just determined by the application code, as it is in simple scenarios where you might go and write some code, compile your code, deploy your code, and then when the first message gets published, and if the schema is missing in the registry, the code will simply go and publish that schema, based on what the current code is, and then start using it. But in many cases, there is more thought given into what the schema should look like, and then that schema is being centrally managed and centrally deployed into a registry, and only then can applications use it. So that's one scenario. And then another scenario is where applications start publishing data, but that data needs to be classified in some way. So applications start publishing data into a system, and then the schemas that are being published are being harvested and then are being presented in a central governance service, where then the schemas and the data that is coming in is classified in certain ways or is analyzed in a particular way to allow for categorization based on what is personal information, what can be hidden, what is permissible, is there information that's coming in which we should reject. So there's all kinds of considerations in often very large organizations which have to do with the metadata or the kind of data that's flowing through systems, which the data protection people, for instance, will want to have transparency on, and schemas are very helpful for that. So that's the governance aspect, why the schema registry is interesting. The schema registry that we have is, I still have the event hubs namespace here, I just see. The reason why I have this with the product polluted here is that the Azure Event Hubs is already implementing the V01 of the schema registry spec that we had in the repo, and so that's as with Cloud 0.1, we're fairly early, and so that's that's the structure that we have in our world. So we have this notion of a namespace that's the host effectively for any schema registry. So in our particular product, we call this hosting scope the namespace, and that is how you reach the schema registry. So the schema registry has a fully qualified domain name. It's a web service. And the registry can be inlined with any other service. So if you have an HTTP interface for your message broker, if you have an HTTP interface for any infrastructure that needs to deal with payloads and needs to manage them, then you can go in and put the schema registry right under it. The schema registry itself starts at the schema group layer, where we have a collection of schema groups. A schema group is a logical container, a repository effectively for schemas. And the reason for why that exists is that you will typically need a grouping based on ownership. So there is a particular part of your application, let's say a microservice, and that microservice is emitting 10 different kinds of events. Then you want to have those 10 different kinds of events. Each of them has a schema, and so you want to have them under one schema group so that the owner of that particular microservice can go and manage those schemas within that schema group. But that owner might not be able to and not be allowed to manage other schema groups. So it's effectively allowing for some level of access control model and organization, top-level organization of schemas based on whatever criteria you want to apply. And then there is schema. The schema itself is a logical construct. A schema has a name, has a type, has a format, has an authority, and the schema type basically determines schema type and format are actually the same thing. Determines the what kind of schema that is, like protobuf or Avro or JSON or whatever you want. Could also be XML. The schema has a name, and then the version inside of a schema is the actual document. So any schema, the schema is basically just a bracket around multiple versions, and each version really is a document that is implementing. So the first schema version is the base version, if you will, of that schema document. And then if you're adding more versions, you're effectively adding more documents into the schema. So the schema is not the document itself, but the schema version is the document. That shows up. The way how this is used is like this, and this is how I just kept that slide in here with the product example, because again we already have that implemented. The one way to use this, and the reason why this is also useful as a general mechanism, is that it's not really dependent on a particular protocol or a particular transport, but it can be used with multiple transports. This is really concerning the payloads of the messages. So you may have a Kafka, so you have a sender that sends into Kafka, and it's using the Kafka Avro serializer. That's a class that we provide in our SDK, before we have an official SDK here. And that's looking at the Azure Schema Registry, which is just an implementation of the API that we are defining here together. And then there's a consumer that's based on that's built into the Azure SDK. So the Kafka producer is built as an extension that fits into the Kafka API. And then the AMQP consumer is a client that fits into, in our case, into the Azure SDK. And both of those talk to the same schema registry, and then the message goes into Event Hubs using Kafka and comes out of Event Hubs using AMQP. But so both of those ends can go and talk to the exact same schema registry. If we were sending the message, if you just imagine the middle to be split up into multiple brokers, it could quite well be that you are sending to a proper Apache Kafka broker, are then using Mirror Maker to replicate that message over to an Event Hub, and then go and consume from Event Hub using AMQP. So that might be a hop in the middle, etc. What matters is that the schema registry can be seen by the producer and can be seen by the consumer, but the schema registry is effectively an external mechanism that is external to the data flow. The reason why why it's kind of inlined into, if I go back one slide, the reason why this is inlined in this, so there's this namespace, the host is here, and then the schema groups are underneath it, is that imagine here in this case, you have this client. And that client can now talk to this message broker, right? Whatever that is. And let's say it's using either the Kafka protocol or the AMQP protocol or the HTTP protocol. And to be able to publish messages to publish new events, it also needs to be able to go and reach the schema registry. More importantly, and if this is centrally governed, then it probably doesn't have to go and publish into the schema registry. But who definitely needs to read from the schema registry is this consumer. So the consumer needs to be able to talk to the broker, but it also needs to be able to talk to the registry. Now, in very many cases, it is so that those consumers and those producers are very constrained in terms of what they can see in the network. So they're living in VNets, they're living behind firewalls, and that's very often the case in messaging scenarios, where messaging is basically builds bridges across isolated networks. So you have this where you have on-premises environments where all the services that are sitting in the on-premises environment are living inside of a NAT or inside of a private network that then bridges out to the internet using a NAT. You have the cases of Kubernetes applications, which all live in private networks with a gateway out to the outside world using a NAT, but only the applications within that Kubernetes application can talk to each other inside of that isolated network. So we have a lot of these segmented networks. And if you have these segmented networks, then it's not clear that the producer and the consumer can see the same registry. So in addition to just having this basic model that I outlined, so having effectively a document service or effectively a document store that has a bit of intelligence and a bit of extra structure, knowing about schema, knowing about versioning, etc. We also need to have some replication notion. The schema registry itself is the first picture is kind of reflecting what I had been showing in the prior slides. First, we have a central registry. So the publisher publishes into the registry all the events that it will publish. It will, in conjunction with our discovery service, it will go and first publish. It will announce all the events that it will publish. So the publisher itself is the service. And it will go and enumerate all the events that it will eventually raise. It will go and make those known into the discovery service. And then also it will go and take all the schemas it will use for those events and publish them into the schema registry. So those things kind of go together. Think of the schema registry as an optional component that complements the discovery service. That's one way to look at it. But you can have the schema registry also work without the discovery service, because in many cases, like today everywhere, because we don't have a discovery service yet, you will look at, you will know what the endpoints are that you can go and subscribe from by ways of some documentation, but you still may want to have a central place where you are storing those schemas. And that's a very common occurrence today in the Kafka world. Everybody knows their endpoints where they can go to, but then they also have an endpoint for a schema registry. And then based on the messages that they get, you can go and take a look at the schema registry and then fetch the right schema for the message that you just got. So that's the central registry case. And the assumption for the central registry case here is that all the apps, this app and this app and this app and this app, have network visibility into this one schema registry. Then there's a version of the central registry where the publisher, and this is from a pattern perspective, exactly the same story, where the publisher will never publish, which means this is effectively for the publisher a read-only thing where you have a central manager, and that might quite well be just be a set of schemas that is being packaged and then deployed with the application, so that it's not dynamic at all. And that is also a form of a centrally governed schema registry, where the publisher doesn't publish, but then the apps can also refer to it. So that's exactly the same thing, but it's legitimate for the publisher to never publish, but the publisher is basically gets a schema that is compiled into it. And the registry is also kind of compiled into the app, and then the apps just refer to it. So it's quite possible for the schema registry model to be quite static and to be also just be deployed along with the applications, and for the schemas to be just part of the code, and for the information model that we provide here to just be used for the applications. And for the schema registry documents, effectively, all that information structure, just to be an organizational guideline without necessarily even hosting a schema registry endpoint. Where it gets a little bit more complicated, and that's the federated story, is when the applications and the publisher can't see each other. And when they can't see endpoints, it can't see joined endpoints. So you have an application that lives in an isolated environment, and the application cannot see the internet. That happens more frequently than most people think. And the publisher also sits in an isolated environment and can't see the internet, or at least it cannot see the same network as the applications can. And we have in cloud events always spoken about multi-hop routes, and that is actually where that comes into play, where you have an environment, let's say an industrial environment where you're publishing telemetry out of machines. Those environments are typically very tightly managed. And now the machine gets an update. There's a new component that's being activated. There's a new field that needs to be emitted, and so therefore there's an update being made into the schema registry, so you can understand the respective data for all consumers. What then needs to happen is that along effectively the flow path of that information, you cannot only replicate the events, and you cannot only replicate the discovery information, but you also need to be able to go and replicate the schema information. And what that requires is that the infrastructure, which means the middlewares that are making this bridging possible across those environments, are then also not only replicating the payload events, which is kind of this lower level piece, but they're also replicating the status updates, the state updates for the schema registry in the same way, and they're also replicating the status updates for discovery in the same way. And that's something that we also discussed, I think, last time in a similar way, just for this. What did I talk about for subscriptions? Subscriptions has a very similar flavor. There, we also need to go and propagate across those environments where. We had the picture. Let me just go and find it because it's the same here. I showed you this picture where you have an application, and I actually showed you this picture. Oh, sorry, that's what I meant. But the application cannot see the publisher's subscription manager, so it goes and subscribes to the nearest subscription manager, and the subscription manager then goes and delegates out that call to this is subscription manager. That's the same kind of reasoning here, and so the same mechanism then applies also to the schema registry. Okay, and then any questions up to here? Okay.
One question, maybe I just didn't get it. So when you want to subject your schemas to review and approval, so how would you do that? Because that's then process before you do the actual discovery or you actually publish it, right?
Correct. Yeah. So that is external. We're basically just saying there are scenarios where the publisher, I think I don't want to mislead to a notion where the publisher always goes and publishes the schema for its events. But the publisher might only refer to schemas that are already stored in the schema registry. So yes, there will be a product which exposes this API that we're providing here, but the way how you fill that registry might only be through the tool and never be through the API.
Mm-hmm. Would it make sense to then try publish some schemas to the registry to see if they work, and then later do it officially once they are live or used? Or would you say it's okay to publish a schema before they are actually used, but then you basically burn the version?
That's quite possible, right? And you would probably do this. You would probably do this in a Q&A environment, anyways. Mm-hmm. Right. So trying things out. I think in my mindset it's always a you would always go and try those things out in a separate environment. Now, can you see me moving this browser window into view?
No.
No? Well, then I have to go and reshare. Hang on. Okay.
Okay. No.
Can you now see the GitHub window?
Mm-hmm.
Okay, great. So let me just go and scroll quickly through this because I already explained everything to you. I just want to go and just point that out. So the schema registry elements here is the schema group. I talked about that and what that has as elements. There's a schema group ID. There's a format, and that format is optional. That applies to everything that is contained inside that group. So you can say, everything that ought to be here, everything that's in that group is all Avro. Then you have a description, and then you have schema version. It talks about the model of the notion of the schema authority, which is something that you have to read through. That has to do with how the replication works, because replication requires that you know where the schema comes from, and where that's so that you don't have avoid duplicates, even though schemas may exist everywhere. Then there's a schema version. And then there's the attributes of the individual schema and where they belong to, where they come from. And then there's the schema version, which is the actual document that has a notion of a version, and that version is something that is assigned by the server. So there's assumption, it's not the schema version here is not a 1.0, 3.0, 15.0, 17b, but it's a sequence number effectively that's assigned by the server. And then if you have another semver notion of what the schema is that goes into the schema document, because all the schema documents are different and the schema formats are different, they have their own versioning notion and scheme. And so this is not trying to replicate that or replace it, but it's really an organizational mechanism inside of this particular schema store. Then there's a REST API that's being defined here. There's also a open API definition for it. And then what I also want to point out is that there's a replication model that talks about what authority is and what central authority means, then how replication topologies might look like. There's a notion of pushing schemas into the registry and kind of replicating them also by push they get propagated. And then there's also a notion of doing pull replication, which means you're attaching a registry to another registry, and that other registry will then go and pull those events out. And a version of that is the event-driven replication, where you are using cloud events to replicate, which means each registry will raise events for every state change. So for instance, this updated event, and for the deleted event. And you can go and subscribe to those. So the schema registry per se will have a subscription manager, and you can go and subscribe to those events. And whenever you receive an event, you can go and come back to the registry with the particular information that you have there, and then you can go and pull the updated schema. So the way how the replication model then works in practice is that you first you attach to a registry. If you want to create always updated copy, you attach to an existing registry. You enumerate all the schema groups and schemas in it and copy them. And then you subscribe, or in parallel, you subscribe to all the updates from that schema registry. And as you're being notified of updates, you then go and pick up those particular changes, and that's how those registries then stay in sync. That is what I had about schema registry. So I encourage everybody to go and read this particular document that talks about it. And I am hopeful for this to be adopted more widely. What I should add here is that even though it is, this is not an accident that this is the name, because it's not really specific to cloud events, as you'll note. This API can be used with anything that passes messages, and really with anything that passes payloads. It's specifically designed so that it can be used with any messaging system.
Okay, cool. Any questions or comments for Clemens? All right, cool. Well, thank you, Clemens, for doing all that. Appreciate it. Oh, sorry, go ahead, Eric.
Are the schema groups and all that all those organizational concepts, are those optional or required?
You have to have a schema group at the top, but you can call that thing default or whatever. But yeah, there's the basic structure requires that you have a schema group.
Okay.
All right, cool. Any other questions? Okay. Again, thank you, Clemens. And I'm back to share here. Now, unfortunately, we only have 5 minutes left, so I don't think we do justice to the 2 extra issues that we have on the plate, our plates. So let me just do this. Klaus, are you prepared to? Do you think you'd be prepared to talk about this one next week? I think you took an action item to write something up. Okay.
Actually, I'm happy that it took so long because I'm not prepared today.
Okay.
Yep. But next week, I think it should work.
Cool. Okay. And John, I assume you'll be prepared to talk about your stuff next week too, right?
Yes, I should be. There's a possibility that I won't be around, but I should be able to let you know beforehand.
Okay. Okay. And then I don't think either one is necessarily too urgent, so we have to wait. It's not a big deal. Okay. Cool. In that case, technically at the end of the agenda, so let me just do one last little thing. Lucas, are you there?
I'm here.
All right. Cool. All right, did I miss anybody for the attendee list? Okay, not hearing anything. I do believe that, except for the SQL stuff, which I said I'm going to try to find someone to take, I think that's it for all the new specs discussion. So thank you everybody that did all that. I think that's it. Okay, any other business people want to bring up that we may have forgotten? And hold on a minute. Let me just double check. I'm pretty sure there's nothing in the SDK group to do. Future topics, nope, we have nothing. So I think we're going to cancel that call for today unless someone can verbally mention a topic they want to bring up. Going once. Nope, okay. I think we're done then. All right, cool. And thank you again, Clemens, for the presentation today. And we'll talk again next week. Thank you, everybody.
Thanks, folks.
Bye.
Bye.
Bye, everybody.
Bye.